All right, we're going to get started here. We expect there will be people coming in. Could be heard word that there's people coming in. So we're just going to go, though. We're going to go with this. First of all, I'll start by introducing myself. I actually don't know everybody here, which is kind of exciting. My name is Christy Boggs. I am one of the co-coaches for the University of Wyoming Nordic Ski Team. I'm also a instructor. Well, I actually work for outreach credit programs, and I work with faculty for teaching at a distance. I'm also adjunct faculty in E&R, and I also teach for the Bachelor of Applied Science program as well. So I'm kind of all around campus a lot. I'm going to give you a little background about the team because I don't think everybody here knows that much about the team. So I'm going to start with a little bit of background about the team. I will go forward one slide. The team has now been in existence as a club sport for about 17 years. Rachel and I were on board right away, so was Becca, one of our very first skiers. We've had a lot of success in that time. We are a club sport at UW, which means that we are very lucky to have $10,000 matched for the year, and that is the amount of money that we get from the university. The rest of it we raise. We have an operating budget if we don't do anything crazy like go to Slovakia of about $30,000, so we have to raise at least 20. And when we go to Slovakia last year we raised about $80,000 so that we could do that. So and part of the way we raised it was through this project. So that's kind of us. We are in Division 2. We raced Division 2. That's the division. We're NCAA Division 2. We raced that. And we also during the year raced in the Rocky Mountain Intercollegiate Ski Association, which is Division 1. So we compete Division 2 at our national championships and during the season, and as well in Division 1. We don't go to the Division 1 national championships. We go to the Division 2 national championships. We have had a lot of success on a lot of levels. For the Division 2, every person sitting in front of you has actually been on a national championship team. All the women won last year, the men won this year, and they're all have been on it. There are actually 4 individual national champions that are involved with this. 3 of them are here. One of them, Will Timmons, who is on this project, is actually in Rothsey, and they're off in Guernsey, killing him off, I think, probably is what's happening. But that's where he is right now. He was really bummed. He tried really hard to stay, but he didn't get to stay. So he's our other national champion that's missing right here. We've had 11 championship teams over the 17 years. That's 6 women and 5 men's teams. And we've had 6 individual overall national champions. So that's kind of like they won enough races, or they did well enough in enough races to actually win overall and be the overall national champion. We have 2 of them in the room right now, Kyle and Sierra, who's behind me. And we've had 26 individual national champions. And once again, there's 4 of them involved in this project. So that's our Division 2. This year in Division 1, actually in Division 1 we've had multiple top 20 finishes, which is really, really great. I mean, we're talking about competing with full scholarship varsity athletes. And we've had several top 20 finishes, and we've had 2 top 10 finishes, both of them by Elise. And we had a top 15 from Sierra this year. And in that race this year, they actually beat 2 fully funded varsity NCAA teams. The women actually managed to take down New Mexico and Montana, I think it was, so Montana State. So that was pretty cool. So why did we go to Slovakia? Why did we go to the World University Games? Last year, the women won the national champion, the men were runner-up. This year, the men won and the women were runner-up. We're trying to get them at the same time sometime. We've done that in the past. We haven't done it recently. We were the strongest team in Division 2 last year. So the company that they have a company that kind of runs the World University Games for the United States, and they pick the top team because they can't really choose individuals because they have no mechanism for supporting an individual. They have to pick a full team. So they picked the Division 2 because the Division 2 is sure to be all Americans, and if you're going to the World University Game to represent the United States, you actually have to be American. So they couldn't take the NCAA teams because the winners are not generally Americans, so they couldn't do that. So that's why we got to go. We did go. We are the only Nordic team representing the United States at these events. We are it. This is the event. The event itself is a very Olympic style event. It has, I can't remember how many sports, like 17 sports. There were at our event for just the Nordic, there were 183 athletes from 28 different countries, and they're all chosen different ways. Most of the athletes that go do this are actually full-time athletes and part-time students. That's not the case with our students. Our students are full-time students and part-time athletes. Actually, I would say they're probably full-time students and full-time athletes is what I would actually say. The full-time athletes will train 600 to 1,000 hours a year and then take a class occasionally. And our athletes actually end up training between 300 and 600 hours a year. And so that kind of gives you an idea of the kind of competition that we're up against. We did have, and multiple athletes in this field, especially the top half of the field, have multiple World Cup and Olympic starts. Like they are the top athletes from their countries fairly often, or right below the top tier of athletes. So with all that in mind, we have what we thought was a great success at the World University Games athletically. We actually had multiple top half of the field races, which we thought was pretty amazing actually. And we had one, Elise, actually got a 23rd, which was really freaking incredible. They probably put her in the top. I tried to count it, and I can't actually tell. It's probably the top 5 of athletes who are actually students. Probably more like the top 3. So that was a really amazing. She actually beat athletes that are professional athletes. That's what they do for real, and they actually get paid to do that. So she beat a few of those. So we had some real good success. I'm going to give you an idea of a day in the life of these guys, because I think it's important to know when you see their presentation on what they actually did. I think you should be impressed, because what they had to do they did this around the edges of the other stuff they were doing. Well, not exactly around the edges, but if it was a race day, they would have to get up pretty early, and they had to go down and have breakfast, and they'd spend at least 2 hours prepping for the race, doing warm-ups, doing wax testing, getting changed, and all kinds of variety of things, all kinds of that stress. And then the race would happen, and even if it was a short race, the races generally takes up at least an hour of your time, and then an hour and a half if you include the cool down and everything. So basically their whole morning is completely shot through like noon or 1 o'clock, and that's just racing. After that, they have to eat again, because they have to eat a lot, and they have to sleep a lot. So they eat, and then they take a nap. And that would be that's a good thing. And then after that, they would often wander around, because part of this is awesome to go see and visit Slovakia and find out about stuff. And then we would eat again, and they would spend the evenings on our really sketchy internet, which it felt to me like if somebody got on, somebody got kicked off type of internet, like, so there's only a few people that could be on at any given time, and it was like us and the Chinese and the Koreans and everybody trying to get on at the same time, and it was interesting. So they were doing all of that, and then they would start working. And like for the wax study, Ben and Sierra would go out after dark, out into the middle of the ski trail somewhere and collect samples of snow, and they're going to talk about that. But that's what they were doing otherwise. And so I just wanted to give you a feel for what this was going to be, what this was like for them, because they weren't just kind of there hanging out doing this cool research. They were actually there racing really hard and working really hard and having a lot of success. So I think that is enough for me.
I think that does a beautiful job of showcasing the nature of the event and allowing you to get the sense of how grand in scale it was, and then even ending with the iconic image of the torch. And that's actually going to come in large part in the presentation that the students are going to do. This academic component of this became a dream for me, as I said, last summer. And it was on one of those very rare moments when we parted ways. We only do so for about 3 weeks of the year. The rest of the year we train year-round. And in that parting, Christy and I, went to bike tour on the Icefields Parkway. And in those moments, I had the opportunity to watch the glaciers and their recession, and to think a lot about climate change. And so it became my dream that we would have an integrated curriculum course that would be action-based, experiential, and very much bring together the nature of training in the outdoors, skiing in the outdoors, and also the health that is needed in order to sustain those activities, and how that related and very much rooted in climate change. And so I cooked up these ideas, and as both Becca and Chrissy will attest, as we were biking along every day, I got more and more excited, and they said, Rachel, this is an unbelievably unrealistic dream, but I said, I want to do it, we have to do it. And so by the time we finished the bike tour, nights were spent reading Al Gore's book, and Four Agreements Alternatively, and I was so inspired that at that moment I made a blog post, and then I came back and I scheduled a meeting with Maggie Broke, and we sat down together, and we began talking, and I said, this is my dream, and Maggie looked at me and she said, that's a thing. And I was like, you're kidding, that's a thing. So from that day forth, the torch was lit for me as well, and I began doing a lot of reading, and I found an article by Tarrant et al. That said that, in fact, if we want to have learning outcomes for global citizenship met, the most effective way to do that is not only by studying abroad, but also by studying sustainability while studying abroad, and that is the most effective way to meet global citizenry learning outcomes. So this synergy allows allow students to be capable of making big decisions when it comes to environmentalism, social justice, and civic responsibility. So we said, okay, let's use this particular article to help nurture the development of our syllabus. And so I started writing the syllabus, and the syllabus started to take form. And by the time we had dinner at the other Maybe loft, and we had the kickoff dinner and fundraiser, I had the syllabus ready to go, and I was running around like a crazy woman saying, Sierra, look at this, Kyle, look at this, does this syllabus look good? How do you think about the learning outcomes? So they were co-developing with me the syllabus that would take form, and at the same time, we began writing a grant proposal, and we wrote that grant proposal to the Hobbs School, and it was a collaborative grant proposal that put together all of the expertise areas of all of our individual scholars and allowed them to use their expert backgrounds in economics, in ENR, in microbiology, and chemistry to address problems of climate change and to integrate them into what we were doing with our competition. And so the syllabus came form, and in it were all of these assignments that they were working so hard on. And what Christy didn't mention earlier is that not only were we asking them to do their research on site for their grant proposal, but we were also asking them to do all the other elements of the course at the same time. So we were asking them to do constant blog entries, constant journal entries, and meeting the learning outcomes in all ways for this course, which did become a 1-credit course over the winter session and a 2-credit course over the spring session. So we've literally been at this for a very, very long time. And I just want to show you some of the learning outcomes. And let me tell you that these learning outcomes, there are 12 of them. And so in this, I am only showing you just a few, oops, I'm functional with this. I'm showing you only just a few of the learning outcomes. So really, literally only 2 of the outcomes of 12 are shown on this next slide. So let's look through some of these. Upon successful completion of the course, the learners will be able to summarize tangible evidence supporting climate change and the impacts of climate change on human health, fitness, athletic performance, and the environment, particularly as it pertains to the sustainability of international Nordic skiing events such as the World University Games. Wow, that's a pretty big goal. We did it. Write an active, reflective journal that integrates competition experience, contextual community engagement, and natural environment with self-introspection and intercultural development. Awesome. So you're saying to yourselves, Rachel, how did you assess those wickedly complex learning outcomes? We used amazing rubrics, and these rubrics really, I know you can't see all of the jazz that's going on in this rubric, but let me just tell you, if you figure there are 12 learning outcomes, I only showed you 2 of them, and I'm only showing you 1 rubric to assess 1 learning outcome. And this actually, these guys got a little familiar with rubrics. So this actually tells you some of the categories on which they were constantly being assessed, all while trying to ski their butts off in the most intense competition in the world. So they were being assessed, for example, on Bloom's application and synthesis, write an active, reflective, and meaningful account of an experience at the competition venue, surrounding the venue, within the community, the natural environment, and I say unique styles are welcome, and they can score on a beginning, developing, competent, or accomplished. I asked them to please show me your environmental cognitivism. They did that as well with the synthetic Bloom's category. If they were to get an accomplished on that, they had to do this. The natural setting or context or environment is expertly woven into the account of the experience. It is rich and integrates a story that describes both the event and the backdrop. So these are the categories on which they were being assessed every day, and the outcomes that we were meeting, all at the same time as also meeting the outcome of having written a funded grant proposal and doing the research involved with that grant proposal. And that's what the students are going to tell you about now. And they're going to talk about the projects that they were researching while we were there at the same time as doing all of these learning outcomes. And I will never forget sitting with Sam and Sindre as we talked about in the hotel about how in the world, Rachel, do I ever get an accomplished mark from you? And we talked a lot about what it meant to be able to delve into the literature and to utilize that to power your speculation, your hypotheses. And so it was a very rich and deep learning experience at the same time as it was a rich and deep athletic experience. So let's hear from them.
Hi, I'm Elise, and I'm a microbiology and ENR major here. And so you guys have all seen images of, say, the moon landing where the American flag is being placed on the moon, or the American soldier who sweeps the girl off her suite in Times Square and kisses her. These are not only like iconic images that capture emotional moments, but they're also important pieces of historical documentation of events. And I decided to take a slightly different approach from many of my teammates. I get a lot of the science side in my majors, and I wanted to experiment with something a little bit different. Microbiology and interaction. Something a little different. Anyway, and so I decided to create a photographic journal of the environmental impacts that I saw along our trip. And photojournalism is a form of journalism that kind of employs images and photos to tell a story. And I wanted to use photos to tell our story as we were traveling across the world. And the purpose of my project was to establish a visual representation of environmental emissions and degradation of an international competition. And I wanted to document both the seen and unseen emissions pertaining to the world universe today. Oftentimes we think of the things that are right in front of us, like trash or waste, but CO2 is often something more untangible, something you can't really see, and I wanted to bring that to you guys. You can think about how our daily activities create emissions. And so I wanted to kind of keep it simple. Before we left, we were reading the book Fevered by Winn and Martha, talking about climate change, how that happens, what contributes to it, and health degradation. And so before I left, I identified major sources of emissions and things like that before we left. And I also decided to use what I had. I didn't want to go out and spend $300 on a new camera, so I used my Galaxy smartphone camera, which is actually better than the iPhone camera. And I took pictures along the way for our whole trip, both our travel and while we were there. So I'm going to start off with kind of a breakdown of my photojournal. I took all my images once I came back, and I kind of separated them into different categories: transportation, electricity use, water use, fuel, waste, and deforestation. And I put each of my images into a category, and some of them overlap, like food would go into like water and energy use and transportation and things like that. And this isn't comprehensive, but it attempts to kind of represent a few of the things that I saw were the biggest contributors while we were there. So to start off with air travel, there were 18 of us traveling across the world, and we were on 4 planes, a day there, a day back. And as a later group will show us, this was one of the largest pieces of our emissions. Planes use a lot of fuel going across the ocean. The groomer. The groomer would get up before dawn and groom the trails to perfect conditions for a race every single morning, for training mornings and race mornings. But then we all noticed that the groomer would sit on the side of the trail idling for hours and hours and hours. And we didn't ever find an answer why. But I found that the 6-piston Bully engine burned about 5 gallons of fuel for every hour of operation. And so that was kind of something that was concerning to me. High fluorocarbon wax, another group will also talk about this a little more later. But this was not only kind of a health impact to our coaches. You can see in this picture, Christy is wearing an air mask as the fumes from the wax to prevent her from inhaling those. So it's not only that, but the irons would also use a lot of electricity. We had about 52 pairs of skis being waxed multiple times a day for multiple races, and then there were 18 of racers there. And also the chemicals from the wax shavings were discarded to go whoever knows where they go. And another piece was water use. It's one of the things that we all use every day. We use it in our hotels, taking showers, all that kind of thing. One thing I did notice, if you look at the image of the toilet, they have high and low flush options, which is something that we've just started picking up on in America, but it was kind of hard to find a toilet without one of those there. More eco-friendly, I guess. Electricity was also a large contributor, burning energy while we were there in the hotel, heating buildings, heating the wax rooms, running the facilities. Another cool thing I found was that the lights in the hotel, when you left the room and took the key card with you, they would automatically turn off. you didn't have the option of forgetting. The World University Games torch. It burned both day and night. It ran on white gas that they imported from Russia, and it was an everlasting kind of reminder of the prosperity and the pride of what we were doing there, and kind of an incessant reminder of both our purpose as athletes here, as well as our purpose of studying the environmental impacts there of our trip. Kind of just a constant reminder. These are a few images I took of the forests and surrounding hillsides. And so first you have to know that these forests were originally planted. It was a touristy area, and it kind of increased the aesthetic appeal. But then a few years ago, windstorms came and knocked a lot of the trees down. And then people came through and cleaned that up. So it looks like it's been clear-cutted, but most of the growing and the cutting and the falling down has kind of created a lot of disrupting of the natural flora and fauna of the area, as well as the ski trails have to cut through the forest area as well. This generator, and this is one of my favorite images actually that I found. An on-site generator was used to run the timing systems and the race course systems for there, and so they were on for almost all the days that we were there, and we wouldn't have been able to participate without this keeping things going. And even though that air transportation was our largest piece of emissions, we also had to drive several hours both from the airport to the venue, and many of the other teams drove across Europe to get to the venue. And many spectators came every day to see the opening ceremonies, the closing ceremonies. I think the president of Slovakia was even there for the opening ceremonies. And spectators would drive up every single day, and it was kind of a remote area up in the high Tatras. And so some things that I just want to reflect on is that one of the largest things I found was the extreme contrast between the very beautiful area and the setting we were of the mountains, very pristine area set aside for kind of tourist areas, very different from most of Slovakia. But that was also contrasted with our environmental impact that we were contributing to there, both the good and the bad. And I also realized that putting things into images can help us realize how our everyday activities and our passions impact the environment. Very often we think, oh, that's the other, those are like big corporations. And one thing I've learned in my E&R class is that it is very personal. And hopefully seeing the small things all add up, contribute to your footprint personally. And I also wanted to bring visual connection to you guys, our home audience, back in Laramie, and to inspire other students to possibly travel abroad more and to travel with an environmental focus in the international context. And so now I'd like to introduce Britta and Sam. They're going to tell you a bit more about the carbon footprint. Thank you.
Hi, my name is Sam Wiswell. I'm in environmental geology and geohydrology, with a current major in E&R, and then a minor in geographic information sciences.
Hi, I'm Britta. I am a microbiology major and an environment and natural resources major.
So we took on the challenge of calculating our carbon footprint for the team over the course of our travels. And a lot of people have heard the term carbon footprint, and it's kind of popular these days, so we thought we'd define it before we'd go off on our journey. The carbon footprint is the total amount of CO2 that has been emitted by the activities of the population. In this case, our population.
And why does it matter to us? Well, the primary driver of human-caused global climate change in our world today is the accumulation of greenhouse gases, with CO2 being the most prevalent of those gases.
So our overall objective for this study we did was to quantify the team's carbon footprint over the course of traveling to, from, and during the World University Games in Slovakia. And this was done with the hope that we could see more effectively the impact we've had from it.
So for materials, to calculate our carbon footprint, we employed the use of two primary online carbon dioxide calculators. One was TerraPath, and the other was the Greenhouse Gas Protocol. So we used TerraPath. It's a unique calculator that has been developed by a team of students at the University of Pennsylvania, led by their professor, or their Dr. Carl Ehrlich. TerraPath has helped thousands of businesses and institutions, as well as hundreds and thousands of individuals, take personal control over their impacts on the climate around them. And we use TerraPass to calculate the emissions caused by our water and food consumption, as well as the emissions caused by our hotel.
The other calculator we used was developed by the Greenhouse Gas Protocol. This is a decade-long collaboration between the World Resources Institute and the World Business Council for Sustainable Development. Works with businesses, governments, and environmental groups around the world to build a new generation of credible and effective tools for combating climate change. We specifically use their mobile combustion emissions tool to calculate our airline and automobile travel.
And these two tools combine to give us a really holistic view of our team's carbon footprint. So when we started this project, we soon realized that there are many, many factors that play into calculating one's carbon footprint. And we came to the conclusion that it would take an army of data collectors and professionals and a whole team of people to calculate a perfect carbon footprint that our team was putting out.
Like one thing that happened when we were there was we were like, okay, how much is this egg going to produce? And you were like, okay, so they drove the egg here and they used fuel to cook the egg, but then they also fed the chicken that laid the egg. And then it just starts going on like that, and you just realize
how many farts the chicken has?
Yeah, all of that stuff. It's like, we can't calculate all that. So we broke it down to 4 main attainable categories that we thought we could quantify. And this was travel, lodging, food and water consumption, and a few aspects we noticed at the World University Games, which included the grooming of the courses and the university outdoor, which kind of captured everyone's attention. And we just basically calculated all this. We put it in Excel, and like on the average day, if we were flying, we'd go in, we'd like look up the plane engine, how long we were flying, the model of the plane, and then the airline company, and then we look all this stuff up online to see what emissions.
Oh, so the food and water consumption that we calculated was we had each students and coaches keep a meticulous log of the amount of food and the water that they were consuming in order to kind of get our grasp around the consumption that we had while we were there.
So this is one little piece of all the calculations. As you can see, we had a grand total of 26.91 metric tons of CO2 that we tabulated. It's important to know that with all these numbers, that this was just for our team. Typical flight going across the Atlantic emits about 300 metric tons of CO2. So these are all just adjusted numbers. And to put it in more of like a graphical representation, we've got these pie charts. And as you can see, air travel absolutely dominated our emissions with 24.37 metric tons of CO2 just from planes. Another thing we thought was interesting was that our lodging and food consumption produced about the same amount of CO2. We were expecting lodging way up.
So yeah, the emissions also caused by our water consumption, the torch that you saw in Elise's presentation, and the piston bully were so negligible in comparison to the rest of our emissions. One really unique thing to our, that was specific to our trip is that the only driving that we did was to and from the airport. And the rest of the transport was just done on foot, basically. We were about 5 minutes from the venue, so we could just walk from our hotel steps to the race course and without having to get in our cars and drive. And so that really cut down our automobile emissions. Well.
So we've already said a lot of stuff on this slide, but I think the real kicker here is what does 26.91 metric tons give actually? So we were really curious about this, and we searched around online, and we found the EPA's greenhouse gas equivalence calculator, and it basically told us that our emissions from this trip was equivalent to burning 28,292 pounds of coal, or about the same amount of energy that the 2.41 homes in the U.S. use over the course of a year.
And they also gave us an interesting bit of information in that it would take 21.6 acres of healthy U.S. forests 1 whole year to sequester this amount of CO2.
So we're going to pass it off to Sindre and tell us a little bit about carbon offset economics of the whole thing.
All right, thank you. So I'm Sindre, and I worked on a project that's kind of an economic spin off of Britta and Sam's, and Will Timmons also worked on this project with me, but he couldn't be here today. So I'm going to talk to you today a little bit about air travel demand and carbon offsets. Our specific objectives are how carbon offsets might affect our demand for travel. So when we buy carbon offsets, it's raising our costs for travel essentially, right? But at the same time, we're internalizing that externality. And then the second part of my project is we wanted to get a feel for how Slovakians felt, local Slovakians felt about the carbon offset, or the idea of carbon offset. So real quick, I'm just going to go over what a carbon offset is, just in case you didn't know. It's when you enact in a carbon emission action, what you can do is you can go and buy I look at it as like a service for programs to offset your emission, and essentially you're help funding your help funding offset projects. So they offset carbon through sequestration or forgoing future emissions. And then the other thing that's important to note about carbon offsets is it's a voluntary market. So as of now, if you travel and you want to offset your carbon, you have to go out and voluntarily buy them. And so there's several providers that provide different offsets. Like I mentioned before, there's tree sequestration and forgoing future offsets. So you have different prices per ton of CO2 that you're offsetting, and that's important to know. I'm gonna go through how we tackled this. The first thing was for us to find price per ton of CO2, and we did that by choosing what we thought were the 5 most legitimate carbon offset providers. And the way we chose that is we found a report by the Clean Air Cool Planet called A Consumer's Guide to Carbon Offset Providers. And so they had a ranking of the best carbon offset providers, and we chose the top 5, and we took their prices for CO2 and then averaged them. From there, we just needed our total air travel expenditure for the team. That includes the tickets from Denver to Slovakia, extra luggage expenses, and a per diem meal estimated food for the 2 days that we were traveling. From there, we needed to find a comparable price elasticity of demand. And so real quick, if you don't know what that is, it's a sensitivity measure of demand. So when prices change, how sensitive are you to prices changing? So if the price changed by 1%, how much more or less do you buy of that good, right? And that's calculated by the following: percentage change in quantity demanded over percentage change in price. And then using that and our calculated cost of offsetting carbon, we can find the percentage change in quantity that we percentage change in quantity demanded that we might have. So first off, our average offset price per ton of CO2 was $14.14. That's the average of the companies that I was talking about earlier. Our estimated team travel expenditure, so that's just for our team to go from Denver to Slovakia to Denver back. And then the average cost to offset air travel emissions was $318. So all that is the $14.14 times how much CO2 we emitted in our air travel, which was 24 metric tons that you had mentioned. Here is a graph just showing you all the companies and the average of our added cost to flight expense. So that's what it would cost in total to offset our emissions from air travel as a team. And that yields percentage change in price, which is really small because you saw that our our total cost of flying there was like 20,000, and this is like around 300 bucks. And then given the price elasticity of demand that we found from a report from the IATA, which is the International Air Travel Association, they produced like a bunch of different elasticities on air travel markets, and essentially we fit into a category that was because you can imagine that demand for domestic flights would be different from international flights and so on. So there's a bunch of elasticities, and we fit into a category that was flights across the Atlantic, flights that were longer than 6 hours, and flights that were to another country, another important factor. And so that yielded a percentage change in quantity, and on average, our quantity demanded would change by negative 1.2% if the price went up by that much. So what does that really mean? What does that mean to have a change in demand of 1.27%? And I thought of a couple different ways of thinking about this. It would mean that of the 15 tickets that we bought to fly there, we would demand 0.19 less tickets. Another way to think about it is we flew 11,670 miles, and we would demand 148 less miles. And then finally, we might want to think about it in terms of the number of trips to WUG every 5 years. So in the last 5 years, we went to WUG 3 times. And this price change would reveal that we would travel 0.0 less 4 times to WUG, which is kind of a weird way to think about it, but it kind of explains it. So like I said, with this elasticity of negative 0.7, it yields a change in quantity of negative 1.27%. And I gave you a way to think about it. So realistically, when we think about going to WUG, we don't think about it in terms of our demand for the travel, right? We think about it like our demand for WUG. We have a demand for WUG. And it has a cost associated with it. And so if we paid the $351 to offset our emissions, would that really keep us from going, the extra 100 miles at the end? It wouldn't. It definitely wouldn't. And so our demand curve, you could say, kind of an imaginative demand curve, is a little bit different than the market demand curve for air travel. It would probably look more like a step function, if you can imagine what that is. Because for changes in price, we wouldn't demand any less trips to WUG until a certain point, until where we couldn't afford it anymore, and then we would demand less trips every 5 years to WUG. Maybe 1 less trip, and then it would go over like that, and then we would have a price range there where we could fund the team to go, every two times every 5 years. So that's but the important thing to notice is that with this elasticity, it could be indicative of our travel demand. And what I mean by that is our demand is probably pretty inelastic, and what that means is we're pretty not responsive to price change. WUG is really important to us, and so a price change isn't going to make us go less. It's going to have to be a big price change, and so that's why it's kind of indicative. And the other reason that the percentage is so small is that, again, I said that the percent change in price is so small, which is awesome because it means that we probably can afford to offset our carbon. So for the second part of the project I talked about earlier, which was talking to locals in Slovakia about, we had a series of questions that was translated, of course, that talked about climate change and the idea of carbon offsets. And so these are the 4 questions. These are the 4 main questions that we asked. How concerned are you with climate change? How much does Slovakia do to combat climate change, or how much do you think Slovakia does? How have you heard of, or have you ever heard of carbon offsets? Do you know what the idea is? And then should carbon offsets be like mandatory? Should we have to offset our carbon like in the future for traveling? And our results yielded that 7 out of 10 people interviewed are concerned with climate change there. It was a pretty small sample size, but and then 9 out of 10 say that Slovakia does nothing to climate change, or they didn't know about anything that Slovakia does specifically to combat climate change. And then only 1 out of 10 of the people that we surveyed knew what a carbon offset was. And then finally, all participants thought that carbon offsets should be required by law. But it's kind of interesting because if they thought that, then why were only 7 people concerned with climate change? So that's kind of interesting. So just really quick, even though there might have been some translation miscommunications, trying to explain what a carbon offset is in English to the translator and then have her perfectly explain it to the local, it might not be perfect. So we know that, but I think we got the point across that if they knew what it was, they would have said something like, "Oh, are you talking about this?" And I think this makes sense because carbon offsets are kind of like an emerging market right now. They're pretty new. And I don't know for sure, but the average U.S. American might not know a lot about carbon offsets, so I don't know if I would expect locals to watch. Next up is going to be the ethnographic perspective group.
Okay, so I'm Kyle, and I'm majoring in microbiology and E&R.
I'm Yara. I'm a double major in architectural engineering and art.
My name is Taylor. I study psychology and physiology.
And our group decided to take an ethnographic approach in terms of seeing how the local community felt about the games and their impact on that area. And we decided to take this approach because rather than handing out a questionnaire that said, okay, you have like these choices, select one and give it back to us, we wanted to hear more about their personal story, and this would capture the intricacies of maybe what they thought about the games, and it wouldn't just give us the averages that might leave out like maybe certain things that they thought were really important to them, how they thought about the games. And pretty much the reason that we did this was because Yara was talking previous about how for the World Cup in Brazil, a lot of the money went to the government after, and a lot of people were not very happy about that. So in the future, maybe it'll be harder for Brazil to have been on that scale. In the same way, if you compare that to this area, we thought that possibly we could extrapolate responses and how people felt in general to see if this was sustainable, that it could happen again. And Taylor is going to explain how they liked this.
Yeah, and so like Kyle was explaining, we decided that we wanted to determine the level of community support of the games and whether or not it could be sustainable in these ways. And so we decided to interview community members and to ask them specific questions that showed how they perceived the games. And to do this, we came up with 5 questions to ask during our interviews. 2 of these questions were designed to give us baseline information, while the other 3 would give us specific information and data that we could use to determine whether or not the event was sustainable. But before we could do that, before we could ask these questions to the locals, we had to have our attaché, which is in the upper right-hand corner right here, translate our questions to the local Slovak language. And you can also see that translation over there on the left-hand corner. And with these translations and our attaché, we were then able to commence the interview process, which took place in the town itself and locations around the venue. And the picture here on the bottom right-hand corner is a picture of the town where we did most of the interviews, and up here in the middle picture on the top is where the venue was. And you can see that the venue is not too far away from the town itself. That's roughly a kilometer away. It was like 10 minutes of walking. So we just walked from the two back and forth, asking people their perspectives, asking them these questions. And so, oh, that's not good. Well, yeah, so this was a slide, a picture of these questions, so you could see them a little bit better, but apparently that didn't work. So these are the two questions that we asked that would give us a baseline. And the first question was asking whether or not they were aware of the World University Games taking place in their local town. And we decided that we wanted to ask that just to make sure that these people that we were asking actually knew of the games and they knew what we were talking about. So we weren't getting random information, random answers. And so as you can see, all of those, all of the people that we interviewed said yes, they did know of the games, that they were taking place there. And then the second question that we asked was if they thought the games were representative of other international sporting events. And we asked that question because we thought it would be best to determine whether or not our data could generalize towards other international sporting events on this scale. And so you can see there that all of the answers that we did get were yes, and then some. We only received a few answers, or we didn't receive a few answers from people because there might have been a translation error somewhere in there. And so Yara will talk about the people that we interviewed.
So we wanted to include photos of the actual people that we interviewed because they tell a different story than we can say with words. We felt like the pictures relate a sense of humor and just convey who the people actually are, which makes them relatable and kind of brings their individual stories home to you guys. So the responses that we received from people I just saw were fairly interesting. The environmental question that we asked, which was basically, do you feel like this event has a positive or negative effect on the environment? We received relatively few answers. We think that this was probably due to an issue in translation. One pertinent response that we did receive was that they thought that the influx of people would add trash to the area, but because they wanted it to be beautiful and look good for the visitors, there were more people cleaning up as well. So it was kind of positive and negative. The economic response was what we would have expected. They said that the influx of people was good for businesses. It added to the economic growth of the location. And the social response was overwhelmingly positive. Everyone was glad for the change of business and happy that they could showcase their area to lots of people. So this graph really sums up the responses. As you can see, the blue is positive. And besides the environmental question, which here we had one positive, or two positives, one positive negative, and then a lot of no response or something that didn't really relate to the question. And then you can see that both of these were very positive. So summing it all up, to us, this really showed a positive indication of sustainability and that the people in this area would like to see other events like this happen. They felt that economically it was benefiting them and it was a thing that they would like to continue.
And it was really interesting too, I thought, because maybe if we went to a more touristy place, these people would have been like, oh, cool, glad you're having fun, whatever. But like our attaché, for example, would come up to us and be like, what do you think of Slovakia? Like, do you like it? Do you think the people are nice? Are the mountains pretty? And I'd be like, yeah, that's awesome. And actually, a lot of people did that. And so maybe it was the fact that this place didn't see a lot of outsiders, and they really wanted to have a more, I guess, global awareness that Slovakia is. So, and now Sierra and Ben are going to discuss the wax accumulation of skiers.
Hi, I'm Sierra. I'm in chemistry, earth system science, and I just added a queer studies minor.
And I'm Ben, and I'm a chemical engineering major.
So we wanted to take a different environmental look at the World University Games, and so we chose ski wax accumulation at Strebski Placeau. And I'm just going to pass around ski wax so you can kind of feel it and get a sense of the material we put on our skis and fast. We melt that on. And so to begin this study, we searched the literature trying to find similar studies and found Klassman, Denninger, and Berger. And basically, they looked at the Vasaloppet in Sweden. Ooh, I have a laser. Okay. So 90-kilometer race, and they sampled at all these points snow and soils. And so this is a chart of the semi-fluorinated alkane concentrations in snow. And you can see there's a lot of semi-fluorinated alkanes at the start, and then it quickly diminishes. That's just an insight, so you can actually see the value there. And this paper just provided basic methodology for our study, and also let us know that soils aren't actually that important because they didn't find any waxes in the soils. So we went from there and found the study that they used to quantify fluorocarbons in soil and snow. And this gave us a sense of the arrangement of ions that we could expect to find on a GCMS spectrum. And you can also note that you can get this same 589, 603, 617 combination at 403, 503, 603, and 703 peaks, which we'll explain a little bit more later. Sorry.
Well, in order to do our wax study, we had to determine a way to get our snow samples back to the United States from Slovakia. And this was our first kind of problem we ran into, and realized we didn't have much experience in this. And so we went looking for a place where somebody would be able to help us with this problem. And we ended up contacting WRI, Western Research Institute, and we talked to this awesome guy, Joe Raboni, who was a huge help throughout our sort of analysis process. But he suggested that we use glass bottles rather than something like a plastic Nalgene bottle, because the plasticines in the plastic Nalgenes would contaminate our sample. And so we ended up using glass bottles, and we contacted a bunch of different authorities in order to determine if we could indeed take water samples back from Slovakia. And we got the okay that it was good to go. And we ended up talking to TSA, and they okayed it that we transport them back in our luggage. And so we ended up getting our wax samples back in our luggage, and thankfully they all arrived safely. Yeah, nothing broke, so we were in pretty good shape. But while we were there, we sort of came up with a standardized way of getting our samples, and we decided that we would take them at 4 different times throughout the racing week. And we determined that we would do it at night after the race was finished, and that we would do it at 3 different places on the course. We would do it at a hill on the course, a flat section on the course, and by the starting line right at the beginning. And we sampled on the 4 separate days, and we sampled by area of snow, and we basically packed the snow into the glass bottles as much as we could and let it melt. And then we flew them back from Slovakia to our lab. And once we had these snow samples, we had to determine a way to get the wax out of the snow, or the wax out of the water, the now melted snow. And what we did was we did a liquid-liquid extraction using toluene, and we sort of used the same procedure that Passman et al. Used, but with one modification is that we used toluene instead of cyclohexane, because we found that the wax that we tested had a better solubility in it. So we used a separatory funnel and toluene to separate out as much of the wax in toluene as we could. At that point, we used a rotovap, that guy right there, to evaporate down our samples to about 1 milliliter. And we were unable to get 100% of the water out of the toluene when we rotovapped it. And so what we did after that was we used a nitrogen evaporator there to evaporate the remaining water and toluene out of our sample. At this point, we had dry wax, we hoped, in the bottom of each of our sample test tubes. And we reconstituted those in fresh toluene and then put them in gas chromatography, mass spectrometry vials in 1 milliliter amounts. So we had all of our wax in our GCMS vials at that point.
So after a lot of work, Joe optimized the GC run. And this is just an example of the HF8 standard wax. We also did HF7 and Hawk wax, which is synthetic fluoro. And this is just a hydrocarbon distribution that we found. And then here are 2 lab contaminants, butyl olate and phthalate, which are ubiquitous in lab environments, so it wasn't unexpected to find. We also had contamination in the blanks, which was really bad. So we had to go back through our methods and try to find where the contamination was coming from. And we did find that the nitrogen evaporation needles matched that distribution from the blank. And so we were able to subtract that from the rest of the samples and hopefully account for that contamination. And then here's the results from the hydrocarbons. You can see the start samples here, the hill, flat, and control. And just like in Passman et al., the start values were higher than the rest. One thing that we had hypothesized was that the hill samples would have more hydrocarbons in them than the flat. And we explained this difference being that the flat was greater than the hill in this case because when you're on a flat section of the course, you can get your skis flatter on the snow. And that allows more surface area for abrasion. And then one thing to note is this hill sample, which is way higher, and that is one sample that experienced contamination possibly more than the rest. It had to be rotovapped twice. And so that's what that's about. There you go. Is it good?
So when we did our analysis, we wanted to sort of follow the Passman et al. Paper, and they focused on fluorocarbon, and we wanted to do more of a quantitative analysis, if that was possible, of the fluorocarbons to see if we could match up with roughly the findings that Passman had. And so what we did, what this shows here, is this is a chromatograph from a sample of the fluorinated, or a section of the fluorinated species we were looking at for, this is sample 11. And it sort of is very similar to a synthetic fluoro, which is the 9Mo50 pure fluorocarbon standard that we use. And we saw peaks at very similar retention times here. And so what we wanted to do was we wanted to do a mass spectrum to see if we could match with the same mass spectrum in the Passman paper and find like the actual fluorinated species that they used in that particular paper. And we did. So in this particular one, you can see that the 403 is the same as one of the ones in the Passman paper. And we were able to find that there was a 403, a 503, and a 603 ion in the standards that we used to compare our samples to an actual sample that we took from our ski wax. And so with this data, we were able to generate a calibration curve. And with that calibration curve, it would take the area under the peaks for the chromatogram and convert that to a fitting curve that we could look at each of our wax samples that we analyzed and then plug in our abundance here into this equation and come up with an actual milligram per milliliter amount in each of our snow samples. And so because we did this, we were able to get more quantitative results as a concentration for our different waxes. And we graphed it out. And we sort of found that for the fluorocarbons, there was a relatively even distribution of wax concentration across all of the different points on our sample. So the hill, the flat, and the start all had very similar concentrations of the fluorinated species in the wax. And we hypothesized that the fluorinated species is, it adheres better to the bottoms of skis, and so it isn't as likely to come off your ski as you're racing. And this day 4 start, this day 4 start here is a little bit of an anomaly. It's actually, the range here is very small, and so if you were to zoom out, it is still fairly close within that area, but it is a little bit higher, and we don't really have a reason for that. And then the hydrocarbon versus fluorocarbon durability, basically what the qualitative hydrocarbon results that Sierra talked about before showed was that the hydrocarbon wax does not adhere to skis as well as the fluorocarbon wax, because we saw that sort of distinct downward trend. So we do think that the fluorinated species is a little more durable.
And that's actually its purpose.
It's true.
Go ahead.
Yeah, so these results support the Plasma et al. Studies in several ways, which we were excited about. So first of all, the majority of wax accumulation was at the start area, wax in general, which they also found. And our course was a lot shorter, so it didn't show as aggressively, like an aggressive drop-off as wax as their 90-kilometer course did. Our course was only about 2 kilometers around. And so it was definitely not as large of a drop as they showed. And our fluorocarbon amounts were very similar. They were both in the parts per billion range, which was basically the same as what they found. And the fluorocarbons that we found at the 403, 503, and 603 mass to charge ratio ions were the same that they identified in their paper, which suggests that the wax that we analyzed was common. It had common fluorinated compounds in it that a lot of ski racers might use.
And then we also had some new contributions to this literature. First, that toluene can be a solvent for ski waxes, and we also did some analysis of injecting that cold versus hot, and there wasn't a huge difference between the two as far as the response from the instrument. Also, we identified contamination sources in the laboratory, including phthalates, butyl olates, and hydrocarbons. And then finally, the importance of this study is the environmental impact, the whole purpose that we started with this. So first, we did find that hydrocarbons and fluorocarbons are measurable in the snow at ski areas. Secondly, we know that fluorocarbons have important human health impacts, so that's why Christy and Rachel wear the mask. You know, it has cancer implications and also respiratory problems. But what are the environmental impacts of this? One you might think of is that fluorocarbons were banned from use of CFCs, because they're major greenhouse gas. They're really potent greenhouse gases. And so if these compounds are able to get into the atmosphere, that could be a potential environmental impact. Also, fluoros can accumulate in water. They're hydrophobic, and so they're not going to be easily degraded or accumulated into bio sources. And so if you think about a ski race area, and we've had experience with start areas mostly being in wetlands rather than in a forest, people don't have to cut down the trees. They can just put down this open start area. And if that's where all of the ski wax is accumulating, then it's going directly into the sources. So potential environmental impacts.
And in fact, right now, Sierra and Ben are looking to try to publish their findings. It turned out to be quite a contribution, and Joe Ravani's help with that has been absolutely invaluable. And so we do want to make a lot of acknowledgments here today, but I think also I just want to take a moment to say that yesterday I spent time, and I know that I was not the only one who was there at the Science Initiative meeting, and one of the conversations that we're having in that forum is about actually bringing active learning to the classrooms. And I think that this is a real moment of celebration of something that to me is the epitome of active learning, where we brought together all of these students' varied interests and not only put them into action in a classroom, but really took it outside of the classroom. And to me, it's more than just the classroom space. It's all about being able to extend beyond that space and to learn how to establish collaboration outside of your own, maybe classroom and or home department, and really start to talk outside of the academic silo that we usually quarantine ourselves in. And so to me, this is where we need to take integrated curriculum, and I'm so excited that there are conversations beginning all over campus towards those ends. And this last summer, I was lucky to be asked to be on a committee. Bill Gurn asked me to serve on an integrated curriculum committee, and Brian Shader was the lead for that committee. And we talked a lot about how some of these things might, come into action. And so I think I am so proud of these athletes, because we have a saying on our team that a hot body is nothing without a correspondingly sexy mind. And that is absolutely the case. And so I hope that these studies show you that, but let us please acknowledge the people that helped us with this. So Maggie is here today. The Hobbs School was one of our primary funders to help us with this project, to allow us to study while we were competing. Campus Rec, Club Sports, ASUW are always huge supporters for us. The Outreach School, Christy and I wrote an innovative course grant. We were granted that grant, and they gave us support for the course portion of this. The international programs actually gave $1,000 per athlete, and a big part of the reason that we got that funding was because of the academic piece. We also get support from the College of Agriculture in more than one way. The SEND grant funded Kyle, Britta, and Elise. And then also John Wilford helped Sierra and Ben as we were literally scrounging to try to create an apparatus for attaching the limiting the flow for the rotovat. And so we got really creative. John studies uranium bioremediation. He had some really cool little valves and whatnot that we were able to hook up. So we got resourceful, and his help was really valuable in that. And then also, Joe's here in just a minute. I'm going to acknowledge him a little bit more. Anna can't be here today, but Anna was the research advisor for Cindra's project. She is a complete economics guru, and she graduated with her master's from UW last year. She is now an economist. She also helped as the coach, so Anna is not only incredibly brilliant, but she also is a phenomenal coach. Cycle Wyoming gives us financial support, as does the Cheyenne Ski Club. Maggie and Nick Murdoch are some of our biggest donors. Ava Bell, Melissa Gangle, our alumni. My mom is here. She's one of our biggest donors. And I did want to thank Bill Gurn and Brian Shader for inspiring integrated curriculum. And so we have a special gift for Joe. I honestly cannot thank him enough. As you can see, the project that Ben and Sierra have done, when they show you this is how scientists, right? we distill months and months of work into tiny graphs that, you know, they tell a story. And then it's here, done that. They've been able to tell a story. But the hours and hours of work and heartache and tears that have been, and moments or tears that I stormed out tonight. And so, Joe, we've got a sign bib for you. You saw a picture at the beginning of all of the athletes signing this bib. And so hopefully this will be able to find some home. And we just appreciate everything so much. Thank you for coming.
We'd love to take questions. If anybody has questions for anybody, please. We'd love to take some questions too. That'd be great. I'm looking at my phone because we have people online that are supposed to email me questions. So, no questions.
I've got a question.
Go.
It seemed like there's a bit of translation error. Where did you find your translator?
She was given to us. We actually, each team gets an attaché that helps translate or helps you with any needs that you may have.
Like sandpaper? We had her running all over the world trying to find sandpaper.
Yep.
And they're actually students too. Yeah, that's right. They're students from the university.
Yeah, and ours was actually really great. We just think that there was, between all of the technical terms and all of there's a lot that goes into that, so some translation stuff. But yeah, we were given our attaché, and she helped us a lot with that.
Well, and were there any like super comical responses that you received to any questions?
We got some interesting ones for sure. I don't remember offhand you.
There was a lot of laughing and then chatter in the slow block, and we just.
Go ahead.
So, along those lines, was the size of the town comparable to Laramie?
It's actually smaller.
It was tiny.
It'd be nice to actually have the same questions here in Laramie.
Yeah.
As a control.
Yeah.
So that's
No, we can. That'd be a lot easier. We wouldn't have to translate.
Big contrast if they're about the same size.
Yeah, it was actually pretty much just the resort. There was hotels, a restaurant, and then shops, and that was it. Nobody even lived there. Everyone that we interviewed came in from visiting town or from other towns.
But the neighboring towns were very close too, so it wasn't. It's not like the Western United States,
And then I have a question for DCM.
Okay.
So how many carbons were these lower carbon?
So they were very large carbon chains. Yeah. So like we ran into some problems because the GCMS device that Joe so graciously let us use could only go so hot, basically. Yeah. And so
340.
what was the max on it?
So goes to temperature about.
Yeah. Yeah, and we were running into like an upper limit on that, and so they were very large PC. Yeah.
I never looked at the
Yeah, probably at least 20.
The hydrocarbons C20 distribution. Okay. Yeah, I'm very good at basic. But there's the same process of nothing.
Questions? Is there a question?
Yeah, I'd be glad to. Mary always has best questions. From the anthropological perspective, did sustainability mean, quote, people want it to keep happening in order to keep making money and have interesting strangers visit, end quote. That is, for an interdisciplinary research project, it seems important to either employ a common definition of what sustainability would mean, or clarify that each team was using a different definition and what that definition was. If ecological sustainability was the shared underlying concern, how might your method, the interview, provide you with data relating to ecological sustainability?
Yeah, and actually this answers Christian's question because, like personally, I think they thought we meant the local environment, not
nature,
trees and happy deer, but like the actual games. And so I think that's why they got confused because that question came after it, and they just be like, "Are you?" So to answer her question.
Ecological sustainability, like how could we get at that with your questions at whether we're defining ecological sustainability or not?
All right. I don't know, better clarify that we're talking about.
Yeah, I think so. And I think, Mary, in retrospect, we realized that we should have said the natural environment because that, you know, we were, unfortunately, our minds were all on climate change and the natural environment. And so we didn't add that really important clarifier. And I think that really would have given us a better response.
Like maybe have it see what the translation in Slovak was translated back.
Yeah.
Maybe.
I remember you guys actually having this conversation and trying to determine definitions for sustainability, and you like started out with this idea of sustainability for like the event happening again, and then there were several levels of that sustainability being you have to have environmental sustainability, you have to have social sustainability, and so all of your parts were like for the games being sustainable, and so that kind of explains that group, and then the other groups were more ecological, or like.
And in a certain perspective, the one model of understanding the whole, right, is the person. And so, in some ways, I think an interdisciplinary collaborative research project can each, in different overlapping ways and in independent ways, address different pillars of sustainability, which is and
yeah, that was definitely right. Yeah, between all of us, we all have different backgrounds, and we each have different and talents, and I'm sure all of you can see that. So I think that was a good goal there.
Yeah. One of the things that just also to Mary's question a little bit is that there are multiple groups and organizing groups that are trying to do completely sustainable events. The London Olympics, they were trying to do completely sustainably. I don't know if they accomplished that all, but that was a goal. I can't imagine they actually pulled that off, but they were trying really hard. And there's a whole series of race series that they tried to do sustainably. So I think, you know, on a very dreamy thing is I'm the president of I'm the vice president of cross country for the national organization, and on some level, I want all this to inform how we might go forward and make a sustainable national event. I mean, that's like Rachel's dream was like, you know, I guess we can do that. Mine, it's a lot more complicated. But yeah, did you have a question, Rick?
Yeah, I mean, like, I guess in relationship to that, like 90% of the carbon was travel.
Yeah.
You know, and like in terms of sustainability, like the social benefit of sport, like it just makes me like not like you guys did one trip. I think about baseball and basketball and football and like the number of planes that are in the air every weekend, year round for sport. And I just wonder if there's, you know, if you guys had conversations about that, how to value sport in relation.
I could probably talk your ear off about that. Yeah, it definitely puts things into perspective. I mean, as they were saying, just for the winter games that we were at, you said there were 17 different events.
I can't be about.
Or something, roughly 17 different events. So that means specific teams for every country that came for each event. And you know, and obviously we traveled along with this in the U.S. Not everyone came that far. I mean, there were parts of Europe that came. So I mean, it's going to vary between each team and each country as well. But at the same time, it definitely opens your eyes a little bit.
Yeah, and I would say that one of the things that we saw was that a lot of eye-opening amongst our students and athletes, and we read Fevered, and Elise made reference to that. It's a book by Linda Marsa that really it's a little bit alarmist, but it does the trick in terms of relating the gravity of the situation, and it looks in large part at vector spread, and so a lot of our skiers are also my advisees in microbiology, so they had a lot of interest in some of the microbiological connotations of changed climate. And there was a lot of sadness and depression going into Slovakia. I mean, there was a lot of feeling like, the earth is dying, this is horrible. And so it's been kind of, I think, an upward, because I'm prefacing this before I read Mary's loaded question. But I think we've now found our way to, I think, a point of optimism, and part of that is this is so cool, we actually have some good friends, one of whom she's a writer, and she actually ended up being good friends with Linda Marsa, so we actually literally, a week ago, sat down and Skyped with Linda Marsa in California, so they got to actually talk with the author of the book they're reading, which was awesome. But yeah, so anyway, I will read Mary's loaded question, but I think Lauren had a question as well.
Go ahead, Lauren.
I just think it would be interesting from sort of a sociological perspective to ask those same questions of people here in the United States and to see what their thoughts were about what is that definition of sustainability. Because everyone has their own sort of silo, right, that they're within, and some people are going to think sustainable, like, can we afford to keep doing this financially? And some people are going to think sustainable, how is this affecting the environment? And so I don't necessarily think it would only be your attache's fault, right, for being able to translate that, but also that those sort of errors in translation, I feel like, would happen here too. Because unless you gave a significant amount of clarification, I think everybody's mind is going to go to a different place. So, if you're a business major, maybe your mind goes over here, and if you're a biology major or an ER major, maybe your mind can be here. If you just finished reading Fevered, you're probably like, so I would. But, everybody's mind is going to go a different place based on their experience too. So it's going to be interesting.
I mean, based off of your conversation, a lot of people's question whether or not it's sustainable in X amount of time.
Not like, are we killing the planet?
Right, exactly. And we're out to, we have to survive first, but so, that's kind of all of it, worms in a sense. But I agree. I mean, 100%. There's definition of it. That would be.
Okay, I'm going to read her. Given the limits of ecological resources, is it not the case that one conclusion from this effort is to clarify that elite international athletic competition is not ecologically sustainable? Or to put it another way, if you guys want to keep doing this, who in the world has to do less in order to sustain your high level of production of CO2? As I understand it, a gallon of gas burns 32,000 calories, while a gallon of jet fuel burns 3 million calories, which tells me that there is no sustainable way to maintain flying as a form of mass transportation.
Well, I think as, maybe not us specifically, but athletes are in a really position that they're under scrutiny from a lot of people. And that puts them in a unique position to change people's minds. If athletes became really aware of how much they were using, and you say Sindra's method of sequestering carbon or doing other things to combat the carbon that they were releasing, that people would see them making that, and they could have a very large effect. Yeah.
I think it's also really interesting that we can pinpoint this airline travel as such a dominant factor. I mean, none of us are necessarily mechanical in this group, but we could start to think, wow, what can we do to make airline travel more sustainable in the environment, in every aspect of sustainability. And that's kind of something we could take away as maybe a call to action from this.
Well, maybe going with that, the question I was just talking about, the huge chunk of the flying, where is that kind of bring? the data that Cindy was able to extrapolate from all the information that he had, it was like $350 for all this. So it's like if every team just spent a little extra money to sequester that CO2, I mean, it's a drop in the bucket compared to everything. I think if everybody saw this information, they'd be like, even if it's not something that they're passionate about, they can still use this information well. We can put these restrictions on people. Teams that you were saying, even with Saints football teams, baseball teams, they're traveling every day, to go to all these different events. That adds so much to the pool, I guess. And so, I mean, just seeing this data here is really an eye-opener as well. To see, it's really not that much compared to how much they spend on food and on flying. I mean, football teams, even the football team here has enough to sequester the carbon emissions.
These guys to tell you, I mean, they've already decided that they had already talked a lot about the fact that as we do this becomes part of our equation for our budget. We have to figure out how to sequester that. Which isn't, like our budget, I just was going over that yesterday, and I mean, we're talking $70,000. We can throw $350, I don't even notice. I mean, it's ridiculous. So,
it also does to put Cinder and Will back when they asked, like, no one knew what a carbon offset was once it was explained. Like, yeah, that should be mandatory. Like, that should be, like, you should internalize that externality.
Yeah,
and
exactly.
That's a takeaway.
This is Willie Via, one of our other assistant coaches.
I think it would be a lot easier to get people on board with offsetting their carbon emissions than it would be with like, hey, stop buying.
I agree.
Stop driving your car, whatever. But to get people on board with that kind of a percentage of what was it, like $20-something thousand of airline tickets? Yeah, it was $350. They already add on all those taxes and fees. There's not that puppy in there.
There are airlines that actually do that.
Yeah.
Yeah, and kind of like on a side note, I was reading Super Economics. I don't know if you've read that. And I think another important piece to this when we're talking about reducing emissions is investment in inventions that reduce emissions for airplanes. And there's this really cool company in Washington, called Intellectual Ventures, right? And they just work on invention all day. And one of the things that they mentioned in the book, because the book had a motif of climate change, was making like airplanes more fuel efficient. And I think that's an important piece on top of offsetting emissions too, and, like something that we should invest in.
Did you see the
invention in cleaner?
The solar plane that just went around the world? That was cool. I mean, they just flew a solar plane all the way around the world. It took them a long time. But they did it. It was possible.
What are so you say offsets? Are you talking like planting trees or like?
Yeah. So kind of like what that's discussed before. So the offset is kind of like a theoretical idea to me. You're essentially paying a group of people or a project that works on sequestration. Or another really good example is there's companies that buy fuel-efficient stoves to ship to people in Africa so that their emissions for cooking are less, and they're essentially foregoing future emissions. And
so you're not like specifying like your offsets. You're just saying like we would pull this money towards offsets in jail.
Yeah. So like you can think of it as in the carbon in the world. So your net change in the carbon in the atmosphere is 0 of the world.
Wait, does that make it just reflect actual environmental costs, or does it go below actual environmental costs? So okay, so say you have like the environmental costs. We can just talk about this later, actually.
Any other questions?
So, yeah, Mary's
killer.
She says, how about a student-athlete strike until UW initiates a matching policy and will make sure all flights include carbon offsets? And she said, Morgan Lovins is another resource. He's working with the U.S. Department of Defense to make flights sustainable. Yeah.
I think that's probably enough.
Yeah,
Unless you guys want more.
We promised to take you out for dinner. We got to get there eventually. Yeah.
Certainly, your guys' personalities were allowed to shine within the animated curriculum. Do you think that made learning more meaningful to you? That's something you'd like to see here more on campus. Or even at your own listen. I don't want to speak for everybody when I say this. I think so, because then, I mean, especially with a project like this, it allows you to really come up with what you think is most important. And so, I mean, we all broke this down and built it up from the ground up. I mean, just through all of our personal experiences. I mean,
yeah, I was just gonna say that we got to apply what we're really passionate about, right? So it became more meaningful to us. And yeah.
It'd be really cool to see it around.
It didn't even really feel like a class to me.
Right. It feels like life.
Yeah, it just felt more like a project. Yeah. No, I mean, yeah, that was cool. I like that.
I think another really important thing is that not only were we able to kind of choose our own passions, but I feel like I learned more from my teammates, like because their passions were part of us. I wouldn't have known anything about carbon, like economic side if they hadn't done it. Like I learned more from that than I would have if I had only focused on like very specific like microbiology. And so it allowed us to know each other in different ways too. That's fun.
That was really good. Yeah. I liked that seeing how the projects changed and incorporated each other. Also, they started out really separate and like we didn't really know what we were doing, and then they all like folded together.
Yeah. And I saw a change in the level of respect that everyone had for everyone else. And on a team environment, that's so incredibly key. Because obviously we have a dynamic of respect based on athletic performance, and there's some knowledge of the academic side, but it really increased that knowledge of just how sexy-minded your peers are. You know, when they're out there killing it on the race course, you're able to also say, and wow, you know, that post she just made on the blog, right? I feel like that was the key element for me to say. Yeah, I think Mary has one more thing. She says, congratulations to all the Scholar athletes. Thank you for letting me listen and participate. I've learned a lot. I welcome you up to the pass into Yellowstone here in Cody. We've still got snow for the foreseeable future, say maybe 10 years. Thank you for coming.
From the health school perspective, we truly over many, many years of administering this health creative activity student experience. This is a stellar, phenomenal set of many different outcomes and all benefits. And so thank you so much for taking our tiny amount of support and taking it. Thank you.